Hi guys, welcome to problem set 51, and today in this lesson we're going to look at two main topics. I have three things here on the board, but they're kind of all connected. We're going to look at imaginary numbers and complex numbers, and then we have something called Euler's notation, and that involves the imaginary numbers. But we're going to start here with imaginary numbers, and we have this imaginary number I. So this I. The definition of this imaginary number I, it is defined to be the square root of -1. Now we've had several problems along the way where we had a square root, and I always made the comment that we can't do a square root of a negative number. We can do any odd root, but we can't do a square root. So it was set up and defined to be this imaginary number I. So we have all these powers of I. I can be to any power we want. And we're going to look at first simplifying those powers of I. Okay? Part of the definition, this I is defined to be the square root of -1. But for most of what we're going to do, we're not going to turn that into the square root of -1. We're just going to leave I as I. That's kind of like I to the first power is I. Okay? Then, by definition, when I square I, when I take I times itself, it's like having the square root of -1 times itself. I squared is defined to be -1. Okay? Then, if I multiply I squared, or -1 times another I get a -1 times I, which is -I. And then, if I multiply that by another I times an I gives me a -I squared. I squared was -1, so I have a -1, which ends up +1. So the big thing here is, let me clear this up. I to the fourth is 1. And let me clean this up. I is just I. Now what we're going to find is every power of I can be simplified down to one of those four things. Either I, -1, or 1. Now the way it works, this I to the fifth power, let's just look at how this happens. I to the fifth power, I could break that down to I to the fourth times I to the first, because I would add those exponents. Well, I to the fourth is 1, and I to the first is I. So I to the fifth is equal to I. So I to the fifth is right back up here. Then I to the sixth would be equal to -1. I to the seventh is -I to the eighth is back to 1. So it's in groups of 4, and it just keeps cycling through like that. So what we'll be able to do is look at this, any number, like I to the 23rd power. I can simplify that down to, again, one of these 4 main numbers. What I want to do is see how many groups of 4 can I get out of that. Well, if you take 23 divided by 4, you get 5 whole groups, and we got to look at the remainder. The remainder tells us what we're going to be dealing with. We would have a remainder of 3. So I to the 23rd is, let me back up, those 5 groups of 4, those are all equal to 1. So I got 3 i's left over. So I to the 23rd is equal to I to the third, and I to the third is equal to -I. Okay, so we can simplify any power of I, again, down to one of those 4 things. All right, let's move over to this Euler's notation. This is what we're going to see a lot of, simplifying square roots that happen to have a negative under it. Anytime you see a negative under a square root, what I want you to think of is I could split that square root of, say, square root of -9 into the square root of -1 times 9. And if we remember our powers or our product rule for square roots, I can split this into 2 separate square roots. So I have the square root of -1 times the square root of 9. What we just talked about, or just defined, that the square root of -1 is defined to be I. So square root of -1 is I, square root of 9 is 3. Now this I, we're going to treat it just like a variable, so I'm going to turn that around and say this is equal to 3I. So the square root of -9 is equal to 3I. Now, we can make this a little bit shorter. What I suggest is anytime you see a negative under a square root, the very first thing you should do is recognize when there's a negative, I'm going to have an I. So the first thing I'm going to do is pull that I out. So the square root of negative 24, I automatically have I times the square root of 24. Now I simplify the square root of 24 just like I've always done. That's 4 times 6. So I got a 2, a 2, a 2, and a 3. So we have a pair of 2's. So I pull a 2 out, times the I that was already there, and I still have that little 3 left inside. So the square root of negative 24 becomes 2I square root of 3. Okay? Next, square root of negative 2. Again, I see a negative under there. First thing I'm going to do is write an I. And then I have the square root of 2 times the square root of 6. Well, putting these two square roots together, I could make that I times the square root of 12. If we break down 12, that's 2 times 6, or 2 times 2 times 3. So again, I have a pair of 2's. So I can pull another 2 out, times the I, times the square root of 3. Interesting, same answer. Did not mean for that to happen, but oh well. Okay, last one. I have square root of negative 5, so right off the bat, that's I times the square root of 5, because there's a negative in there. Same thing with the second part. These square roots are multiplied together, so I'm going to put a multiplication sign there. And then another negative under the square root, so that's another I outside, and the square root of 15. So I'm going to put these things together. When I multiply these i's I can multiply together and say that is I squared, and then the square root of 5 times the square root of 15. 5 times 15 is 75. So now I squared, if you look over to the left, we have this table. I squared is equal to negative 1, so I can change that to negative 1. And then simplify the square root of 75. That's 3 times 25, so 3 times 5 times 5. So a pair of 5's. Pull that out, times the negative 1. And a little 3 left inside. So negative 1 times 5 is negative 5 times the square root of 3. Okay? Last part, complex numbers. Complex number is, if you remember early on, you talked about sets of real numbers. You have the natural numbers, which are inside the whole numbers, which are inside the integers, which are inside the rationals, which are inside the reals. Okay? Complex numbers are the next set outside of the real numbers. Okay? We throw in this imaginary number I, and a complex number will always be written in the form A plus BI. So we have a real number part, which is this A. Now it could be a decimal, could be a fraction, could even have a square root involved. But we have a real number part, and then we have our imaginary part, which is that B part. When you write these numbers, always put the real number part first, followed by the imaginary part. So that I is always put on the end. Okay? These i's we're going to treat just like a variable. We're going to combine them when we have like terms. We're going to simplify the exponents. So again, we can get it down to one of those 4 powers of I, negative 1, negative I, or 1. And then just combine what we can. So let's look at this first problem. We have 4 plus 6i plus 3i minus 2. First step is we're just going to approach this like combining like terms. So combine the real number part first. We got 4 minus 2, that is 2. And then combine the imaginary part. Positive 6i plus 3i gives me 9i. Now, again, don't confuse it. Don't make it I squared. We're just adding them. It's just like 6x plus 3x. It just becomes 9x, or in this case, 9i. Okay, I can't go any further than that. I don't have any like terms. I can't simplify the power of I. Simple as that, we're done. Okay, next example. We had a bunch of i's put together here. So your book does this as an example, just so you see the i's put together. We can treat it just like a normal variable and rewrite that as I squared. So 2i squared, this would be 7i to the third plus 2i minus 4 minus. Now, this last one, square root of negative 3. Very first thing, you got a negative under the square root. So pull out an I. Put an I out front, and that leaves just the 3 inside. Remember that square root of negative 1, that factor of a negative 1 under the square root, gives us that I outside. All right, now we change these powers of I to one of those 4 powers, either I, negative 1, negative I, or I. So I squared, we look over at the table, I squared is equal to negative 1, so I can replace I squared with a negative 1, minus 7, I to the third is equal to negative I, plus 2I, 2I just stays 2I, minus 4 minus I square root of 3. All right, we're going to simplify this the best we can. 2 times negative 1 is negative 2. Negative 7 times negative I becomes positive 7I, plus 2I, minus 4 minus I square root of 3. Okay, we combine what we can. First, combine your real number parts. Negative 2 and negative 4 makes negative 6. We combine the imaginary parts. 7I plus 2I gives me 9I minus I square root of 3. Now, this last step is a little bit confusing. Normally, we would probably leave it like this because of that square root, but the imaginary part, we want to pull that I out. So we can rewrite this as negative 6 plus. I'm going to pull a 9 out of the, or an I out of those last two things, and I have 9 minus the square root of 3 times that I. I know it looks kind of weird, but we always want to put that I term out there by itself. Okay, make sure you leave that other stuff in parentheses. That's really important. All right, kind of wrote over this last problem here. Let's draw a line. This one involves simplifying these powers of I. So, again, every power of I simplifies down to one of those 4 things. So we just go through one at a time and rewrite this. 5 times I to the third becomes negative I, plus 3 times I squared is defined to be negative 1, plus, now this one has an I is I squared, so this is 7 times negative 1, plus 4, plus 2 times I to the 7th power. I to the 7th power. How many groups of 4 can we get out of that? Well, we can get one group of 4, and how many do we have left over? Again, if I split this up, this would become I to the 4th times I to the 3rd. I to the 4th is 1 times I to the 3rd. Again, I to the 3rd is negative 1, or I'm sorry, negative I. So 1 times negative I is negative I. So I to the 7th is equal to negative I. So I replace that with a negative I. All right, let's start simplifying. 5 times negative I is negative 5I. 3 times negative 1 is negative 3. Plus 7 times negative 1 is negative 7. Plus 4. Plus 2 times negative I is negative 2I. All right, we combine our real number parts. Negative 3 minus 7 plus 4. Negative 3 minus 7 is negative 10, plus 4 is negative 6. Imaginary parts, negative 5I and negative 2I is negative 7I. Okay, we have it in the form A plus BI. I cannot do any more simplifying. That's our answer. Okay, again, remember, powers of I. I is defined to be the square root of negative 1. We can simplify every power of I down to one of the 4 things. I, negative 1, negative I, or 1. That cycle just keeps repeating over and over. So simplify every power of I down to one of those 4 things. We simplified square roots of negatives. Anytime you have a negative under a square root, pull out that I first. That negative becomes an I out in front of the square root, and then simplify the square root just like normal. but you have that I tacked on. And then simplifying the complex numbers, a plus bi, you're combining like terms, simplify your powers of I, and just try to put everything together. Okay? This is lesson 51. Good luck.